3 into 3y.
You just need the gradient of the line.
Okay. So do we want like x and y on both sides? So on the right.
I would make y the subject.
Okay. So it'd be 6x minus 2 equals minus 3y.
Yeah.
And then we divide both sides by minus 3.
Yeah.
Which would be minus 2x. And then do we do minus 2 divided by minus 3?
Yep.
Which is just 2 over 3. So
yeah.
add 2 over 3.
Yep.
Which equals... Would that be just y?
Yeah. And so what is the gradient?
The gradient is 2 over 3.
That's the y-intercept.
So minus 2x.
Just minus 2 is the gradient. Okay. And so what is the equation of the line? It's parallel to this line that has a gradient of minus 2 and goes through 0, 3.
Pardon?
And so what is the gradient of the line? What is the equation of the line that has a gradient of minus 2 and goes through 0, 3?
It would be y equals minus 2. Would it be minus 2, just minus 2?
Minus 2x.
Okay, minus 2x. And then plus 3.
Yep.
Okay.
Because the y-intercept is 3. And so for this one, if it's parallel, then it has the same gradient.
Yeah.
So you make y the subject, work out the gradient for this one.
Yeah.
And then sub in m and c into y equals mx plus c.
Yeah.
Okay, let's see. I'm not going to do those. Let me go to my other exam questions that I brought in. Okay, we're not there yet, I don't think. Okay, let's try this.
Okay. So, could you put that as a simultaneous equation, the first one?
That would give you where they cross over. Let me think about this. That might... No, I think that would create more problems. You're trying to find the gradients of each line.
Okay. For both equations?
Yep.
Okay. So for the first one, it would be 3x minus 2 equals y.
Mm-hmm. And so what's the gradient?
So is that just 3?
Mm-hmm.
And then do we do the same thing for the second one?
Mm-hmm.
Okay. So it'd be x minus 6 equals 3 minus 3y. And then you divide both sides by minus 3. Which would give you... would it be x over minus 3?
Yeah. Another way to write it. It's basically 1 divided by minus 3. And it's like minus a third. So you could write it as minus a third x. It's a different way of writing x over minus 3.
And then it'd be 6 divided by 3, which would give you just plus 2, and then equals y. So the gradient is minus a third x.
Just minus a third.
Okay.
3 and minus a third, are they parallel?
Yes.
They're definitely not.
They're not.
Because they're not the
They-
same.
They have to be the same number.
Yep.
Okay.
When you multiply 3 by minus a third, what do you get?
You get minus 0.3.
Calculator.
Okay. Minus 9.
3 times minus a third?
Oh, times. Sorry. Minus 1.
Therefore, they are perpendicular.
Okay.
If two gradients multiply to give you minus 1, those gradients must be perpendicular.
Okay.
How about B?
Well, hasn't B already given us the gradient?
Yeah.
So we don't have to do anything with it right now.
So first one, we don't need it.
Okay. So you plus y on both sides, which gives you 2x plus 4 equals y. And then you know the gradient, which is 2x.
So parallel, perpendicular, or neither.
So we know they're not it's not parallel.
Yep.
So then you multiply them.
Mm-hmm.
See if they're perpendicular. It gives you 1, so it's... Wait, would it be perpendicular if it's 1?
Has to be minus 1.
Okay. So it's neither.
Yeah. Well done. Ba-ba-da-bum. Not parallel. Yep. I just want to see. And then the other one, yeah, they multiply to make minus 1, so they're perpendicular. Okay. How do we do this?
Okay. So it'd be you'd minus 2y on both sides, so it'd be minus x minus 8 equals minus 2y. And then you divide both sides by minus 2. Which would give you... Would it be... Would it just be 1 divided by 2 is 0.5, so a half.
Yep.
It would be a half x. Yeah, just half x. And then plus 4 equals y.
Mm-hmm.
So we know the gradient is a half x.
A half?
Just a half, yeah.
Mm-hmm.
And then do we need to substitute 5 in to x for the gradient?
So we want the equation of a line.
We know the y-intercept's minus 7, so would it just be y equals a half x?
No. Equation of a straight line, y equals mx plus c.
Yep.
This line is perpendicular. Any idea how you get the... So it won't be a gradient of a half. We want the perpendicular gradient.
So we need to make it minus 1.
Yep. So a half times something gives you minus 1.
So if you just do in the calculator half times minus 1.
No. The easy way to find it is the negative reciprocal. So you change the sign and flip the fraction. So at the moment it's plus a half, so it becomes minus.
Minus 2 over 1.
And what is 2 divided by 1?
Just 2.
Yeah, so it simplifies to minus 2.
Yep.
So the
And it's okay. Go ahead.
So the gradient for our line isn't a half, it's minus 2.
Okay.
So, okay, so we still need C.
What, isn't C just minus 7?
C is the y when x is 0. When x is 5, y is minus 7. And so,
Oh.
yeah, so how can we find C?
Wait, so when it's 5, the y-intercept's minus 7.
When x is 5, the y coordinate is minus 7. So when x is 5, y is minus 7.
So do we put minus 7 as y at the start of the equation?
Yes. You can sub x and y into this equation to get C, but not into the original one. That's what you were thinking.
So it'd be minus 7. So you substitute x as well?
Yep.
So it'd be minus 7, minus 2, brackets, 5, close brackets, plus C.
Yeah. And don't forget your equal sign.
Yeah. Wait, so then we just do minus 5 multiplied by... No, minus 2 multiplied by 5.
Mm-hmm.
Which would give you minus 10. So minus 7 equals minus 10 plus C. And then you'd plus minus 7 on both sides.
I'd plus 10 on both sides.
Oh, yeah.
That'll get it in one go.
Yeah. Which would give you minus 17.
Calculator.
Minus... Oh, it's minus 7 plus 10. Just plus 10.
Mm-hmm.
Which is 3.
Yep. And so what is the equation of the line that's perpendicular to that and goes through 5 minus 7?
So it'd be y equals minus 2 x plus 3.
Well done. Y equals minus 2x plus 3.
Yeah.
So find the gradient of the first line. Negative reciprocal. So change the sign, flip the fraction for that gives you the perpendicular. 1 over 2 times 2 over 1 gives you 1, and then plus times minus gives minus.
Yeah.
And then sub in m and y and c. Sorry, m and y and x into y equals mx plus c.
Yeah.
These. So that's question 11. That looks familiar. It's not the same as that. It looks similar. Okay, let's try this one.
Okay.
It's an exam question.
So you want to work out what y is first.
Okay. Maybe.
So we write out 4y minus 8 equals 3x.
I mean, maybe we don't need the y coordinate. I don't know. Okay, go on. We might need it.
Okay. 3 minus 3x on both sides, which would give you 3x minus 4. No, minus 3x plus 4.
Hang on. Why would you do that?
because you said we might need to do that.
You're trying to find y. Is that what you're trying to do?
Yeah.
In that case, so you're trying to move things away from y. Don't bring things onto the same side. Bring things on that side to the other.
Oh, see, is that okay? So you can just plus 8 on both sides.
Yep.
Which would give you 4y equals 3x plus 8.
Yep.
And then you divide by 4 on both sides.
That's it.
Which would give you y equals 3 over 4x plus 2.
That's it.
Then can we... Do we substitute 4 in?
Yep.
Okay. So it'd be y equals 3 over 4 brackets 4 close brackets plus 2.
Mm-hmm.
And then we work that out. So 3 over 4 multiplied by 4 is 3,
Mm-hmm.
which gives you y equals 3 plus 2. And then you add them together, which gives you 5. So y equals 5.
Mm-hmm. Okay, what's next?
So 5 is the y-intercept.
It's the y coordinate when x is 4. So when x is
Okay.
4, y is 5.
So now do we just use the same equation, y equals 3 over 4x plus 2, but substitute 4 and 5 in?
If you do that, you'll just get 5 equals 5. We want the equation of a line that is perpendicular to this one and goes through 4, 5.
So do we need the reciprocal
Yep.
of 5?
Of the gradient.
Oh, so okay. So would it be written out as y equals minus 4 over 3
Yep.
x? I just minus 5 over 4 over 3. And then
No, go on, you can do the full if you want.
y equals minus 4 over 3 x plus 2.
Not 2. Can't assume that.
So it's just c.
Yep.
And then you substitute y in.
Yep.
Which would give you 5 equals minus 4 over 3 brackets 4 plus c.
Mm-hmm.
And then you work out what minus 4 over 3 minus 3 multiplied by 4 is. Which is 5 equals minus 16 over 3 plus c.
Mm-hmm.
And then you plus 16 over 3 on both sides.
Yep.
Which gives you 31 over 3. So 31 over 3 equals c.
That's it. And
So now we have y equals would it just be minus 4 over 3 x?
Yep.
Plus 31 over 3.
Mm-hmm. So usually you'd
And
be
then-
finished, but yeah, go on.
And then you take away y on both sides,
Mm-hmm.
which makes it minus 4 over 3x minus y plus 31 over 3 equals 0.
Yep.
And then, do you do anything else here?
A, B, and C are integers.
So do you need to get rid of the 3 in the bottom, so you multiply everything by 3?
Well done.
Okay. So does that just give you minus 4 for the first one? Minus 4x?
Yep.
Minus 3y plus 31 equals 0.
And that should be it. And they might multiply everything by minus 1 and get positive 4x plus 3y minus 31 equals 0. And
Yep.
that way they have only one negative instead of two, but it's the same thing.
Yep.
Do I have the answer to that? I don't, but that's it. Yes. Okay, so your instincts were good, but I wish you'd read the question. Let's see. You make it y equals. Use that to get the y coordinate. Use that to get the negative reciprocal of the gradient. And then sub x, y, and m2 in the perpendicular gradient into y equals mx plus c.
Yeah.
Okay. Any idea how you do part A? Might not be obvious.
So for this question, do we just want y at the start of the equation?
Yeah, that's a good start, I think.
Okay. So you divide everything by 2, which gives you y equals a half minus 1.5
Yep.
x.
So how do we show that 3 minus 4 lies on this line?
Now do we substitute 3 and minus 4 in?
The way I would do it is, and I think the way they like it set out, the way it shows it, is if you sub in just 3 for x.
Okay. So it'd be y equals a half minus 3 over 2 brackets minus 4 close brackets.
Not minus 4.
Oh, sorry, 3.
Yeah.
And then you worked it out, so it'd be minus. Which gives you y equals a half minus 9 over 2.
Yeah, there's no extra marks for any of that. You can just put the whole thing in your calculator.
Okay.
And so what would you get for that?
Half minus 9 over 2. That gives you minus 4.
Yeah. And so that equals minus 4. And so that's a way of showing it. If you sub in both, you end up getting like minus 4 equals minus 4. So yeah. I suppose there's nothing wrong with it. But if you sub in 3 for x, you should get minus 4 for y. You know, it's a pretty good way of showing it.
Could you sub in minus 4, just minus 4, would it still work? Would it give you x? Or is that not possible?
It would take more work if you put in minus 4 for y. So then you have to subtract a half from both sides and divide both sides by minus 3 over 2 to get x equals.
Yeah.
Because you already have it as y equals, it's much easier to just sub in 3 and calculate and get minus 4.
Okay.
Okay, B.
So now we want the reciprocal, don't we?
Yeah.
So it's all 3 over 2 is already a minus, so what happens is it become positive, so it'd be 2 over 3.
Yeah.
Okay, so y equals a half plus 2 over 3x.
No, not a half. In general, your answer is going to be y equals mx plus c.
So it's just c.
Yep.
So y equals 2 over 3 plus c. X, 2 over 3x plus c.
Yeah.
And then you substitute x and y in.
Yep.
The coordinates.
Mm-hmm.
So it'd be minus 4 equals 2 over 3, open brackets, 3 plus x. And they worked it out.
Mm-hmm.
So it'd be minus 4 equals 2 plus c. And then you just add minus 2 on both sides, which gives you minus 6 equals c.
Yep.
So it'd be y equals 2 over 3x. Is that right?
Yep.
Minus 6.
Yeah.
But they want them in integers.
They want them as integers. 0. So that part you're okay for. And then you just multiply.
Yeah.
Multiply everything by 3. 2x minus 3y minus 18. Yep. That's grand. So the important bit is just the bit in the middle. Negative reciprocal, and then yes. Okay. Any questions about that?
Nope.
Let's see what these things look like. Find it great. Yep. All right. How do we do this?
Okay. So we plus 5y on both sides.
Yep.
Which gives you 2x plus 2 equals 5y.
Mm-hmm.
Then you divide by 5 on both sides.
Yep.
So it'd be 2 over 5x plus 2 over 5 equals y.
Mm-hmm.
And then you have the gradient, which is 2 over 5x.
Without the x.
Okay, yeah.
Yep.
So that's the first part of the question.
Mm-hmm.
Yeah. Okay. Now we want... Okay, so now we written out as y equals minus 5 over 2x plus 2 over 5.
No.
C.
Yep.
And then you'd substitute the points in, the coordinates.
Yes. And then you just finish that off.
Yeah.
That goes there. Then you get what C is. Da 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 da. Why do you keep making that mistake with C? It's a different line. Okay, let's see. So these might be the ones that I've been looking for. Yeah.
Okay.
These K types. Okay, part A.
So do we want to put... We want to minus 5y on both sides.
You could.
So instead, do we plus k on both sides if we want k?
Yep. Great.
Okay.
Great idea.
So it'd be 5y minus 2x equals k.
Yep.
So is that k?
Find the value of k, so a number. And they tell us that this line goes through the point 1, 3.
So do we substitute 1, 3 in?
Yep.
Okay. So -2 stays as -2. Wait, no. 5, -2 stays as -2.
Mm-hmm.
It should be 15 -2, which gives you 13. So k is 13.
Very good. Let me see. Okay, and the rest of that is pretty the same. Let me see. The line L2 crosses the x-axis. So let's say L1. So this L1 up here, we now know it's 5y minus 2x plus 13 equals 0. Might be minus 13. Yeah, I think it's minus 13 because that was a minus. How would we figure out where this crosses the x-axis? So imagine that was the question. The line L1 crosses the x-axis at the point P. Find the coordinates of P. So how do we find out where this line crosses the x-axis?
Do we make x a subject?
I'm not sure. What do you know about the x-axis? Or anything we know about any point on the x-axis?
Like it's negative.
Well, this one over here is positive.
Okay.
Any point on the x-axis? What do they all have in common? So it could be 3.50.
Oh, wait. They're on the line 0. The y-axis is 0.
Yes, the y-coordinate is 0. And
So would it be written out as -2x minus 13 equals 0?
Well done.
And then do we substitute x in?
We're trying to solve for x.
So we make x a subject.
Yep.
So it'd be -13 equals 2x.
Mm-hmm.
And you divide by 2 on both sides.
Yep.
Which would be,
I think it's minus 6.5 or minus 13 over 2 is fine.
-13 over 2 equals x.
Yes, I suppose. Okay, so I suppose as a coordinate it's minus 6.5, 0. But if they want to know where it crosses the x-axis, make y 0. Where it crosses the y-axis, make x 0.
Yeah.
That's just a little extra thing there. Actually, that one's looks the same. Oh, this is bringing together lots of stuff. The line L2 passes through the lines intersect at S. It's just a big long question. Let me go back to these other exam questions. Coordinates of A, so that's very similar. This looks weird, but I do like when they give me diagrams. The line through A and B is perpendicular. Yeah, find the value of C. Oh, that's much harder than it looks. Alright, let's do it.
Okay. So do we work out A and B first?
What do you mean by that?
Do we need to work out A and B to get C? Or no?
Like A is 0, 4. What I think you'll need to work out is the equation of the line AB.
Of which line?
Going through A and B.
Okay. So would you use y equals mx plus c?
Yep, you could do that.
But you don't know what the gradient is. Could you still substitute the points in?
You could use that to find the gradient.
So would you substitute both of them into the same equation?
Yep. No.
So,
Well, you can't sub them into the same equation. You have to pick a point, like one is x, one is y.
so could I just use a?
Yep.
So we're in ours 4 equals m brackets 0 plus c.
Yeah. I'll write it as 0m plus c. Okay, what would be the other one?
Y equals
Not y.
0 equals, sorry. Minus 3x.
Minus 3m.
Oh yeah. Plus c.
Yeah, or I suppose like m minus 3.
Yeah.
Okay. How can you get the gradient?
Would simultaneous equations work with this?
Yep.
Okay. So be written out as 0 plus 1 equals 4 and minus 3 plus 1 equals 0. So x is 4 over 3 and y equals 4.
So c is 4. We knew that bit. That's like the y. And x is like m.
Yeah.
4 over 3. So calculator doesn't know it should be m and c. They're just saying
Yeah.
x and y. Okay, how can we use that to get the other one?
So if A and B are perpendicular, does that mean B and C are perpendicular as well?
A and B is the same line. Yes, the line through A and B is perpendicular to the line through B and C.
So is B a shared point?
Yep. And those two lines are perpendicular.
Okay. So dry it out as so could you write out the equation y equals 4 over 3 x?
That would be if it was parallel. These are perpendicular.
Would it be the reciprocal then?
Yep. Negative reciprocal.
Y equals minus 3 over 4
Yep.
x plus c.
And
then you substitute would you substitute c's coordinates in?
And what are those coordinates? Oh, we don't know c's coordinates.
So do we substitute b's in?
Yep.
Which would give you 0 equals minus 3 over 4 brackets minus 3 plus c, and then you worked out.
Yeah.
Which gives you 9 over 4. So 0 equals 9 over 4 plus c.
Mm-hmm. We want C.
So then you just minus 9 over 4 on both sides.
Yep. And so what is C?
Which gives you minus 9 over 4.
Yep. So C is minus 9 over 4. And so this C here is minus 9 over 4. Because that is the y-intercept for the other line.
Yeah.
Great. So you had to find the gradient for this line and then use the negative reciprocal of that to find the y-intercept of the other line.
Yeah.
That's a good question. Okay. Okay, parallel and perpendicular lines. What do you give yourself?
Between a tick and a half.
That's the sweet spot. Not too easy, not too difficult. I think we did this. This seems familiar. Yeah, I'm sure we did this. That's a reminder. That's what that is. I'm not going to do those. Oh, good question. Okay, how about this?
Okay.
How do we start this question?
Well, we know the y-intercept's minus 8.
Yep.
So we'd write out as something, comma, minus 8.
0 minus 8 is the y-intercept. We want the x.
Yeah.
We want the x-intercept. Where it intersects.
So do we plus 8 on both sides?
Big picture. What do you know about a point on the x-axis?
That the y will be 0.
Y is 0.
Yeah.
Yep.
So it'd be written out as 0 equals 4x minus 8.
Yep. And so x is 2. And
Yeah.
so that would be 2, 0. So the other one is when x is 0, y equals minus 8. And then this one is when y is 0, x is 2.
Yeah.
That's just big picture there. Okay, find the midpoint of each line. What's this first one? Between 1 and 5.
2.5.
You add the two numbers together and half it.
So it's 3.
Yep. Next one.
5.
Yep. How about this one?
Okay. 6. That would be 3, comma 5.
Yep. And so it's the same idea as this. 3 is the midpoint going across. 5 is the midpoint of the y's. And so overall 3, 5.
Yep.
What formula can you make? I'm not doing that. Okay, how do we do this?
Okay. So we'd work out the midpoint of the red line first.
Yep.
So the midpoint is 14, comma 12.
Okay. What is next?
Then Would you use like 12,9?
Like to do what?
Would you like to work out the top part of the dotted line, like the top point?
Not possible. It's a line that goes on forever.
Okay.
What form what are we aiming towards? What answer are we aiming towards? What form will the answer take?
Y equals
Yeah. In general, y equals
mx plus c.
Yep. Find m, find c. That's all you need.
Oh. So it'll be 14m.
Hey, ho, none of that. I wrote m from midpoint to u, and I used a capital M.
Oh.
So the midpoint is 1412. M is gradient. How can we get the gradient of the blue line, given that it's perpendicular to the red line?
Could you substitute one of the coordinates in?
Which coordinate?
15, 16, 15, or 12, 9.
Neither of those go through the, well, sub it in. Okay, sub it in.
For which one though? Does it matter?
No.
Okay. To be 9 equals 12m plus c.
Mm-hmm.
And then do we just want c?
We want m.
So we minus c on both sides, so it'd be 9 minus c.
How did we get m for this one? We got...
Oh, we did both coordinates.
Yep.
So the other one would be 15 equals 16m plus c.
Mm-hmm.
And then do we minus c on both sides?
That's long, man. Calculator.
Oh yeah, simultaneous equations.
Mm-hmm.
So right now is 12 plus 1 equals 9. And then 16 plus 1 equals 15. So x is 3 over 2 and y equals minus 9.
Minus 9.
Yeah.
Okay.
And then you'd write out as y equals minus 2 over 3 plus c.
Very good. Don't forget the x.
And then do you substitute either 16, 15 or 12 and 9?
Neither of those are on the blue line.
So you substitute 14, 12, the midpoint.
Yes, and that's why you find the midpoint.
Yeah. Which would give you 12 equals minus 2 over 3 brackets 14 plus c. And you worked it out. Which gives you minus 28 over 3. 12 equals minus plus C. And then you plus 28 over 3 on both sides.
Okay.
28. Which gives you 64 over 3 equals C.
Yep. And so, answer.
So the answer is y equals minus 2 over 3 plus 64 over 3.
So y equals minus 2 over 3x plus 64 over 3.
64 over 3.
And there might have been one of those times everything by 3 questions. I don't know. 0 equals minus 2x minus 3y plus 64. You never know. That's a pretty elegant question. Let me just... how much of this can I clean up? Hey, that worked out well. Yeah, so you can see how with just very little, and even if I got rid of that, and I just said like that shows they're perpendicular. So with just 2 coordinates, we had to do a lot of work there.
Yeah.
This is not the last question in the chapter, but it's the most challenging because it involves everything that you previously learned. You have to find gradient, you have to find perpendicular gradient, you have to find midpoint, you have to find equation of a line. And you're just like very little information, and it's this, long question. In general, let's see. You have to find the equation of the blue line. You know it's going to be y equals mx plus c.
Yeah.
To get m, you get the gradient of the other line, and you do negative reciprocal. To get c, you need a point that is on the blue line, and we're told that it goes through the midpoint of the red line, so you use the midpoint.
Yeah.
And you sub it all in. Any questions about that one?
No.
So perpendicular bisector. Cutting something in half is called bisecting in maths. You just found the equation of a perpendicular bisector. Did I write this stuff? It reads like I did, because I used to teach a girl and she had real difficulty, and that's why this is planned so meticulously. I just want to go for exam question. So that's where this chapter kind of ends. There's something wrong there. I could have done more. Let's see. Oh no, something's very wrong. But let me just see. Equation of the line. What did you do, Dara? Okay. Let me just see. This appears to be like a test at the end. I have pages and pages of stuff. See, yeah, it's the same thing. Length and area. I think I skipped that. Modeling with straight lines. Length and area. Just want to make sure. L1. Just looking, is there a perpendicular bisector question? No, it doesn't look like there is. Okay, so there's one thing at the end which is called modeling, which is applying it to the real world.
Yeah.
My least favorite of all worlds, but hey ho, it's the one we live in. And so that stuff, what would you give yourself?
For all of that?
Yep.
Like today?
Yep.
Between a tick and a half.
That's all right. Yeah, so this perpendicular bisector thing is a very good thing to do at the end, because you need to use everything to do it.
Yeah,
That's what's good about it. Yeah, how was that for you, Adam?
that's great.
So continue this next time. We'll probably finish this chapter.
Yep.
Okay. Any questions for me in general?
No.
All right. Well done, Adam. You did great. I look forward to chatting again
Thanks.
next time.
You too.
All right,
Bye.
thank you. Take care. Goodbye.
You too. Bye.